Alright, problem 9. Crishy crushing through this. I think this is a sick problem. Carbon-14 decays at a rate of 0.012% per year. We're told a piece of wood from an archaeological dig is being carbon-14 dated and is found to have 70% of its carbon-14 remaining, and we want to use that information to estimate the age of the piece of wood. Okay, so what does that mean? Well, let's write a poked model, right? Exponential decay. So, population after time t will equal the starting population times e to the power of the rate of decay times t. Now, we're told the rate of decay, and we're told we want 70%, or we're told there is 70% remaining, which means we're going to end up with 0.7, 70% equals e to the power of our rate, which is 0.012. Oh, but that's wrong, because that's a percent, and we need to enter our rate as a decimal, so it actually should be 0.00012. You catch that? 0.00012 is equivalent to 0.012%, in the same way that 25% as a decimal is represented as 0.25. Right, you need to move the decimal place 2 spots to make it a percent. So 0.7, which first off, why did I get 0.7? Well, we played the game on the other one. Imagine that I started with a 100-gram sample. I would have 70 grams left if 70% remained. Then my first step would be to divide by the 100. 70 over 100 is 0.7. So 0.7 equals e to the power of 0.00012 times time. And we want to find time, so solve this for t. So for t, we'll give you the natural log of 0.7 divided by, that should probably be negative since it's decaying. So natural log of 0.7 over negative 0.00012 should give me t, and you can cross that in your calculator. And holy bungalow, we figure out that this thing is 2,972 years old. We get some decimals too, 291. That's really old. It's a very old piece of wood. All right, part B, how long would it take for an object to lose 25% of its carbon-14? So, if 25% is lost, how much remains? 75%. So 0.75 has to equal e to the negative 0.00012t. And so ln of 0.75 divided by negative 0.00012 has to equal t, which should be 2,397.351 years. It should make sense that it's fairly close to the last one. It's within, 600 years. Because 75% remains versus in the other one, 70% remained, right? So it's not taking as much time. Last one, suppose a tree fell 400 years ago. How much of its carbon-14 would remain? So we don't know how much carbon it's starting with, so this is going to need a percent. So our starting population, P naught, should just be 1. By making it 1, that's saying it's 100%, essentially, right? So what we need is the population at time 400 years needs to equal e to the power of our rate, which is still negative 0.00012 times time. And when we solve it for t, which means we need to do the same exact thing we've just done like 12 times, right? Except that's a lie, because we know the time. We know the time is 400. So this one's actually just plug it and chug it, homie. Type that in. E to the power of negative 0.00012 times 400. It's going to give you 0.95313, which tells us that 95.313% will remain after 400 years. So still a good chunk of the carbon-14.